Welcome back, everyone. Today is going to be part 2 of our Unity UI tutorial. For today's lesson, we're going to be working on creating a button, looking at options for hit areas, fills, texts, adding icons. We're going to be looking at turning that button into a prefab, understanding how prefabs work, and we're going to be attaching a script so that we are able to listen to when the user clicks on that button and have a response to it. So we will start out back in Unity, of course. And I've still got my sample scene from last time. You can see if I jump over to the game view, I've still got my cube and my capsule. I've cleared out my canvas. I just have the canvas object. I've removed any children from the canvas, those images that we were working with last time. I just removed those. That's all. So other than that, it's a pretty empty scene here. And the canvas, I have currently set this render mode to be screen space overlay. So this is again going to render on top after Unity renders everything from the camera views. We're going to be putting a UI element over the top of that view. So here's our game view as it is right now. All right, so let's just get right into it. So first thing we're going to do for our button, we're going to create. You can go straight to the button component, and this will bring in, and we'll show this actually. Let's do this. You can see this brings in a button, and you're going to have to import the Text Mesh Pro package in order to work with the Text Mesh Pro component, which is generally the component we want to be using for displaying text in our game. So I'm going to go ahead and just hit import. This will pop up when you try to add the Text Mesh Pro component, or when you try to add a game object, like a pre-made object that uses the component as we just did. This will pop up. You can say import, and you should in your, there we go, in our console, we get this message that it was imported. The button grays out. And if we look in our directory structure, we can see that a Text Mesh Pro directory has been added. And so now we have those needed dependencies to work with the Text Mesh asset. So you can see in addition to that, when we did this, we got a button game object, which has by default a canvas renderer, an image, and a button component. As a child of the button, sub game object, we have a text game object, which has a canvas renderer, a Text Mesh Pro text UI component, and that's it. The button component has a few different things that are already linked up when we bring it in like this. And we'll go ahead and we'll leave this in the canvas, and what we'll do is we'll create a secondary button from scratch so you can kind of see how all these different components work together, and how you're able to change the structure to kind of get what works best for you and your project, while working within the requirements of the button component. So this is the simplest way to do it, right? We have one game object that just has an image right on it. The image is the thing that actually registers the click. You can see this raycast target. That means that when the user is clicking on this image, a raycast is made. It says, okay, did we touch a pixel of this image? Yes or no? And if the answer was yes, then that gets picked up by the actual button component. And then it can respond to that user input. You can see here that the button has the target graphic. So button can be interactable or not, right? Of course, we want people to be able to touch it, so this is currently checked as true. If you turn this off, it will disable the button. And as you'll notice when I did that, I'll hop over to the game view real quick. When I change this interactable on and off, you can see it's actually changing the color of the button in the view. That has to do with the transitions that are currently set up. We have default transitions. When we bring in a button component, it starts out by default with this color tint transition. And you can see the target graphic came pre-assigned because we brought it in through this pre-made button component. this target graphic is already assigned to the image component that is on the button game object. So we are transitioning the color tint on that image component here and setting it to these different states based off of, so the button will enter these different states based off of whether or not it's enabled or disabled, and then the user's interaction with the button. So we can go ahead and show some of this right now just to kind of give you an understanding of what these different button states are. We can leave the normal as white. I'll change the highlighted to a kind of a orangey thing. The pressed color will go to a darker orange or a red. The selected color will go to a green. And the disabled will make this a little darker gray so we can see it a little better. So again, setting the button to disabled or not, interactable, changes it to that disabled color. I'm going to go ahead and just hit the play button so that I'm actually able to see the rest of these states. So entering the scene, here we are. You can see when I mouse over the button, it enters the highlighted state, right? When I push down on the button, it enters the pressed color state. If I move my mouse off, I'm still holding down, it's still pressed. If I release, it now goes to the selected color state, even though I was off the button. And you'll notice it stays in the selected state. So once you push down and release on a button, the button is registered as being selected. And even though I'm not actually pushing on the button anymore, it still says, oh, well, that's the last thing that you interacted with. That button is still the selected item. If I click off of it in the blank space here, we'll see the button returns to its normal color. So just a quick, overview of how these different states work, right? We've got the highlighted, we've got pressed, which is up or down. And again, I'm holding the mouse down right now, even though I'm moving off of it. And regardless, I think that we'll have to test this real quick, but I'm pretty sure if I release off of it, I believe that the on-click listener does not fire because we released off of the button. I don't think it counts as a click, even though this button then goes to this selected color. We'll have to test that, but I'm pretty sure that down and up on the button will give a different response than down and up off the button. We'll come back to that later, of course, as we continue to program through our button component. Obviously, you've got a couple other things to control this transition, color multiplier, fade duration. You can see, there's this little, it fades between these two. It's a little bit fast. We can, of course, set this way up to 1, and then you'll see a much slower fade transition between these states. Set that back to 0.1. For the button component, we have other options for transitions. So we can do color tints. We can do a sprite swap, which is just the image itself. I'll switch over to this real quick. You can see it's the color's gonna go away because I'm now messing with the transitions. We still have this target graphic, and instead of setting different colors to tint the target graphic, what we're doing is we're setting different sprites to swap out with that target graphic. So we would have a default sprite, and then we might have a down state or pressed state sprite. And that's where we would use that. Alternatively, we can do animations. The animation system within Unity, it's very powerful, gives you a lot of options, and you're able to essentially define an animation as a set of property changes on an object. You're able to change really anything about that object that you can select and change through the inspector. Those properties can be edited or adjusted in an animation, and that animation can be told to play when this button is going to these different states based off of that user interaction. Right now, we don't have anything set up in these animations, so even though I'm pushing on it, we're not going to see anything just yet. Animations, there's a lot in animations, so we'll come back to animations as its own little topic in a bit. Lastly, on our button component, we have the on-click area. So this is where we can actually connect the button presses, the user interactions on this button. We're going to connect that to a listener, different kind, a listener that will then handle the press, and whatever game logic we write, it can respond appropriately. So as just a real quick demonstration, I will add a new on-click listener. So this is where we're going to take a reference here. It needs to know, okay, I've been clicked. Where am I routing this message to? What's supposed to happen? What is the receiving object? Things like that. So one of the easiest things that we could do is I can just drag this button game object into this reference field here, drop it, says okay. On this button, when we receive a click, what are we doing? So if I drag, open up the no function drop down right now, it says no function. It's not tied to any function. We want to affect, we have different options. You can see that they are currently, all of these are related to this specific game object, the button game object that I have put in this field. When I open this up, I see the game object. This is that literal game object. I'm able to affect certain things about it, such as the layer, the name, whether or not it's active, some other things there that are default to game objects. We're also able to affect the rect transform. So again, this button, it has a rect transform component. This component on our button object is what we are seeing in this list. We can affect all of these different properties on that rect transform, through this button click. We have the canvas renderer, we have the image, and we even have the button itself. So one thing that we could do as a starter, just to demo this, we could say that we want to set the game object, our button game object, to false when we click it. And if we come back in here, I'm going to switch this back to color tint real quick just so we can see what's happening. I come in here, when I click on this button, boop, it disappears. And you can see in our hierarchy here, the button has been grayed out because it has been turned off in our scene. This checkbox right here, this is sort of whether a game object is active or inactive, right? That's what this checkbox up here represents. It allows us to control. So by saying to set the game object to false, when we click on the button, this game object is being turned off. We could, of course, also, instead of the game object, we could target the button component itself. And we could say that the button component becomes disabled. And so now, when we come back into our game view and I click on the button, so now the button object, you can see it went back to white, and when I try to hover over it, I get no more response. So the button component has been, notice this checkbox here, the button component has been turned off. And again, that's just responding to this on-click event. We are calling this specific action or this specific property, this method, this property, whichever we're choosing. In this case, the button.enabled property. We're setting it to false because the checkbox is not checked, and that's why we get this checked here. If we were to turn this back on, we're saying set the button enabled to true. When we click it, it's already true. You really wouldn't see any effect at all, right? So just a quick primer on how the on-click method allows us to set receivers and then respond to those click events. Okay, so from here, I think what we should do is, I'm going to stop the scene, and we'll construct our own button in a way that is a little more flexible and will be better for, a more flexible UI layout and sort of giving you a little more, some more options in your design as you're going about, creating new buttons for your interfaces. So I will create a new empty child, right? So we're going to do this one from scratch. Unlike the button component, this one, which we brought in through game object UI button, Text Mesh Pro, we're going to go ahead and create our own. I'm going to move this one, let's see, position, if I say minus 100, and that's 0, good. This one, we'll put this one at plus 100, just so it'll be over to the right-hand side. I'm going to switch to the scene view so we can kind of see what we're doing a little bit. So here's our old button, here's our new button. And you can see by default, it just came in with this width of a height 100 and a height of 100. We can go ahead and just make this a little bit more like a regular button. We'll go ahead 200, sure. And I'm just going to drag it over a little further. Okay, so now we have our top level game object that we're going to use to create our button. So if we look back at our reference button, the things we need to have are a button component, of course, and we need to have an image that gets clicked or something that will be able to register the user's click that has a raycast. And that's kind of it. That's all that you really need for this button. The text child, this component, this is visual only. If we turn this off, the button will continue to work totally fine. Just won't have a label, which obviously is sometimes important. So for our new button, we can go ahead and we're going to start by adding that button component. Now, one thing to notice or to note is the button component, the button component will listen to clicks that happen anywhere in its child hierarchy. So the image component doesn't need to be on the button, the same game object as the button component. The image component can exist as a child of the button component. So you can see right here, it says you must have a graphic target in order to use a color transition. In fact, in order for the button to do anything, we need to have some kind of an image there. So just to show you how this is working, I'm going to add an on-click listener. We're going to do the same thing we did before. I'm going to say, okay, when I, you know what, actually, let me do this different. I will do it to this other button, right? So when we click on our new button, I'm going to tell it to turn off, set active, false, the left-hand button. And when you click this reference here, you can see it highlights, in our hierarchy, just so you're able to see. If you double click it, it actually goes to that object. So clicking it once will highlight the reference in the hierarchy. Double clicking it brings us to that actual reference in the hierarchy. Okay, so back to new button. We're saying that when we click it, we want to turn this one off. So now if I run this, I have a vague understanding of where my button is over here, right? If I try to click anywhere, it should be in this area somewhere, right? If I try to click anywhere in this area, I'm not getting any kind of a response. This other button is still active. If I create a, let's see, okay, so I'm going to create a new child on this, create empty child. And again, notice we're still in play mode. We can make these changes while we're in play mode and we will be able to see the results of them. However, when we exit play mode, all of our changes will get erased. Changes that you make to your scene while in play mode do not persist. So this is okay for creating things to show that for testing things, because then when you're done testing, you stop the play mode, it reverts back, everything will return to the way it was. But if you're trying to test things with the idea that, okay, I'm going to get my scene looking exactly the way I want while it's in play mode, and when you end it, it's going to go back to the way it was before you entered play mode. So this is not necessarily a good idea if you're actually making changes that you want to save. Just good for testing things on the fly. So if we just add an image component here, right? We've just got an image, got a new button. We haven't even hooked it up as the target graphic or anything like that. We should be able to come over here, and if I click on it, oh, look at that. Our other button disappeared. So again, all I did was add an image component, which is accepting raycasts, and when we clicked on it in the scene, that click was passed up to the button component, which is as up on the parent game object. This event was kind of bubbled up, as they say, bubbled up the hierarchy. It was caught by the button component, and it called the on-click listener to disable that other button in the scene. I'm gonna hit the stop on the play. You'll see the scene's gonna return our image game object and all this. This is gonna disappear as soon as I hit stop. Boop, back to where we were. Okay. So what we need to do again, we are going to create this empty child with an image component, And now we have something that we can click on to trigger our button. Now, this brings us to the topic of hit areas, right? So you have the button, it has a visual, but the visual area and the area that you want the user to be able to actually touch to trigger this button, they may not be the same. Usually your hit area may actually be a bit larger than the button. You know, you may only need a graphic to indicate, okay, here is the button, but in order to properly capture, you know, misclicks, big fingers, whatever it is, we need a hit area that's a little larger. So we can use the fact that these click events will bubble up. We can use that to create a slightly more complex hierarchy that separates the visual, which is really just how we're going to message to the user, this is a button, and the click area, which is actually accepting that target interaction. So this we will call our hit area. I like to, you need to put an image on it, right? The whole point is it's going to capture the click. So it needs to have a raycast, something that will accept the raycast, which in this case is going to be our image. I will often turn my hit areas bright pink or bright red so that I'm able to see them. And I know if I see them in my scene, I know that something is wrong because they're easy to identify. And I'm also going to just real quick use our shortcut here to expand the rect transform of the hit area to match the rect transform of its parent component. All right, so I'll start by doing that. And now I have a hit area that no matter what, no matter how wide or how tall I make my button, the hit area is expanding to the entire size of the container for right now. Okay, so this hit area, we'll leave that pink so we can see it just for the time being. The next thing we're going to do is add the visual. So as a separate game object, I'm going to create a button fill. This may also take an image, and what we'll do is, this is the actual display piece, right? This is the piece that the user is going to see, and the piece that needs to be updated for different user interactions, like the hover, the put, the selected, all of that. So this is the graphic, the button fill, that we're going to add as our target graphic. So again, we're going to take this button fill, just drag it into this field here, release, and now the button fill is assigned to the button component. The button fill, our child button fill game object is assigned here as the target graphic, and that graphic will receive the tints as things are changed. I'm going to just set these back so that we can see them. And actually, this might be a good opportunity. Here we go. We can use a copy and paste, save ourselves a little time. This button component. If I copy the component, go over to our new button, paste the component values, and now this one also got overwritten, right? This target graphic was still pointing to the old button, because that's where the old button's component was pointing. I will just update that one and say, hey, point at my button fill on my new button again. Okay, so now we've got our color transition set up here, and we should be good to go there. So other components of buttons, right? So the text label. This one is set as a child of the button. This one, we're going to kind of do something similar. You have some choices here, right? Depending on exactly how you think you're going to, the needs for your specific UI, the needs for your specific button, whether or not the button label, as I will call it, whether or not this sits as a child of the button container or the child of the fill, that's kind of up to you. I usually will keep it separate from the fill. I have all of my different components, separated out. That way, each visual piece really is independent of the others. If I put it under my button fill, if for some reason let's say I needed the button to not have a fill, it was just a text, a text field that the user was going to click. If I turn that off, well, now my label, which was a child of the fill game object, that also gets disabled. So by keeping it, oh, let me go back, there you go. So by keeping it as its own child, not a child of the button, not a child of the fill, we're able to have it as its own separate display element. And we will add a text mesh pro text UI component. That is how we display the text. And this is our button label. You can see this by default. This came in with a white label color or a light gray. We're going to go ahead and make this black so that we can see it. There are some other options here, right? On your this is a text field component essentially. You can set the fonts, you can set font styling, font sizes, etc. Colors, alignment, of course. For a button, we probably want middle alignment, and we probably want vertical center alignment. Depending on what you think is going to happen with the scaling of this UI, maybe you want auto size, so that as this button grows within its containers, that the text is scaling up or shrinking, whatever, appropriately. But if what you may need, depending on your use case, right, is just a fixed font size. You're also, for the auto size, you're able to set min and max values for this. So a lot of options. For right now, we're just gonna get this label on there. We're not gonna worry about pixel perfection design as of right now. This is all about just the functionality side and how to set up your components properly. Okay, so we've got our fill, our label. These also by default, right? These come in as being raycast targets. So we have the text mesh pro also. This also under extra settings, I believe, yes, raycast target. So right now, the label and the fill and the hit area are all raycast targets, all capable of accepting user input and reporting that upwards to the button component on the parent game object. There's no reason, as far as I can think of, you might save some performance by turning off these things, but honestly, I don't think for the most part it's really necessary when we're looking at talking about the UIs that we're going to be making. It's far too early to be worrying about optimization of components at this point in time. So, but just a note, right now we are currently accepting clicks on everything. If we really wanted to make sure that these were purely visual components and not capable of accepting input, we could turn the raycast target off for the button fill, and we could turn the raycast target off for the label, and now only the hit area is the thing that's reporting those clicks up. So that can be nice because now we're able to isolate the exact element that is reporting those clicks, and it sort of helps us, prevent misclicks or clicks from components that we weren't necessarily expecting. Sometimes I've run into cases where I'll have a text field that is bigger than, in order to just allow the text to flow freely, the text field is much larger than, potentially, it might overrun the bounds of where I think the user is actually going to click or where I want the user to click. So anyway, just a note on that the, you can set this raycast target off if you are running into issues where things are not registering clicks the way you'd expect. So, okay, at this point, I'm going to take a quick look back to our lesson plan. The button fill, the button text. Okay, button icons. All right, so another common thing is to have an icon on the button itself. We can create another game object child. We'll call this one icon. I'm going to add an image component. And let's see if we have, I guess for now I don't have a good image to use. I'm just going to use this knob image. It's just a circle, right? So we'll say that the icon that we're going to put on this button is a circle. And so this is where we're going to start getting into using our rect transforms to lay out the different pieces, the different visual pieces of our button in a way that will, play nicely and will scale and all of that. Okay, so for the icon, I'm going to choose to anchor the icon to the left-hand side. And I've got, so you can see I set the anchors to X anchors, min max 0, so all the way to the left. And my right anchors are 0.5 and 0.5. For the Y. So yeah, so I'm sorry, not the right anchors. The Y anchors are 0.5 and 0.5. So I'm using an absolute height here. I'm using an absolute width also. It's just anchored to the left-hand side of my container. So let's see. I am thinking that, for my icon, as my button size changes, let's go ahead and I'm going to turn off the old button for a moment. So we're just looking at our new button. I'm going to center this. Let's see, 0.5, 0.5. Okay, we'll just center this in the view for right now. So x equals 0. And we're going to expand this out a little bit. Let's see. Width of 300, height of 100. My button label, let's see. I want this to be on a single line. So I'm going to turn the text wrapping mode to no wrap, which will force it to be a single line. And I'm going to tell it to expand to fill the entirety of my button container, right? So obviously we're getting here. We've now got a label, we've got an icon on the left, but the label is getting covered by the icon. So what we probably want to do here is to move it to the right-hand side a bit. So now, some decisions here. If we think that we want to dedicate 25% of our button to the icon, well, I'm going to shift my text fields min x to 25% of the parent container. I could switch the icon. We could say that the max is going to be 0.25. I'm going to zero out these other values, right? Okay, now we're pushing we've said that the icon can only exist between 0 and 25% of the button. The label can only exist between 25 and 100% of the button, right? So they're sharing a boundary at 25%. And on my icon, I can choose to preserve the aspect ratio so that rather than having this icon scale to the height of the button or fill out and stretch, right? So I've turned off preserve aspect. As I increase the height of my button, the icon was not set to expand as well. So if I set this to 0, right, this to 1, 0 these out, I'm saying that the icon's container or the icon rect transform, right, it is allowed to stretch to the full height of the button. Now, even after I say that, I can still force the image on the rect transform to preserve its own aspect ratio so that the image that is inside of the rect transform on our icon game object is not a stretched image. It is preserving its aspect ratio. And so now, no matter what size I make my button, the icon stays. If my button starts to get smaller, it's actually going to continue to respect the aspect ratio, and it should shrink the icon down. Yep. And again, our icon is still, it's anchored to that pivot point 0 with the min 0. If we shift this to 0.5, we say that our pivot point is in the middle. It moves our icon to the middle of its rect transform. And so now, regardless of again, it's going to scale that button up the icon will scale it up as much as it can or down while preserving the aspect ratio, and the positionality of that icon has been set based off of the pivot point and our anchor points. The button fill at this point, okay, so we've got I've managed to mostly, I've got the hit area is doing what we really want with it, expanding to the size of the overall container. But the button fill currently is still set to an absolute size. So what we're going to do is I'm going to tell the fill to expand out so that it is filling the size of the container. And this is where we can actually kind of, decide how we want to do this sizing. At a high level, we're going to save this button as a pre-made component. We're going to then be able to drop it back into our scene, create copies of it, and we may want to be able to easily adjust the size on those. So, where do we want to adjust that size, right? We probably don't want to have to come in every time that we, make a copy of this button, come in here and say, okay, the fill this button is now, instead of being 300 tall, now I'll make a copy just of this real quick. So I'm going to copy and paste. I've got now 2 new buttons. I'm going to call this, just for clarity, left button. This one will be right button. I will move the left button to minus 100. I'll move the right button to plus 100. Is that enough? Nope, they're still touching. Go 200 and minus 200. Okay, there we go. So again, when we bring in this new button and we say, okay, this button actually needs to be a bit taller, right? This is a more important button. We need to make it larger. Well, we managed to make some of it larger, but because of the settings we have, the fill didn't actually expand all the way out. And so I would have to then come in here and change the height on my fill to match the height of the container every time, right? So what we want to do is set up our child rect transforms for the hit area, the fill, the label, and the icon so that, pardon me, when we bring a brand new button, when we copy and paste this prefab into the scene and we change the size, we can do it in one location on the top level game object, the actual button container, that parent game object. We'll set the size there, and all of the children will kind of configure themselves appropriately. So the button fill, we're going to say, okay, the fill of the button should match the size of the parent, right? However big we make our parent, we want the fill to match it. The hit area, so depending on exactly, how much wiggle room you need in detecting hits, you may want to give this maybe an absolute pixel value. We're going to say, okay, going to go minus 20 in all of the directions. So we're actually creating an extra 20 pixel margin or padding around the visual that will still detect the hits. And so what I'll do is I will change this color. So this is the hit area, right? We have left it as bright pink and visible while we're doing our design, but what we're gonna actually do in our game, right? We don't wanna see the hit area. The pink should not be visible. So what we'll do is we can take this alpha all the way down, and even though that it's no longer visible, even with an alpha of 0, it will still capture clicks, right? And just to demonstrate that, we've got our color tints on, we've got our hit area. I should be able to come in here to my right button, and even before, you can see, even before I get over the button's fill area, I am hitting that the hit area box, and it is responding appropriately, right? And I can click down and trigger it as well, of course. So now we've got a hit area that is slightly larger than the area we defined for our button. We've got a fill that responds to the sizing that we set on our parent. We have a label, which, if we would like, we can also say auto size, and when we change the size on this component, I'm going to shrink the width, you'll see that text is now also scaling down appropriately. And the icon, the icon is, I think should be set to, at this point, scale appropriately with, whatever the settings are that we've got. So this is how I will usually choose to construct my buttons so that as I'm going through iterations, as I need to change icons, icons may change sizes, they may have different, the icon itself may change aspect ratios as you're doing iterations, like different images, have different actual dimensions. The label, all of these things are separate and can be turned on and off without affecting the overall functionality of this button component, right? The hit area. Let's see. I guess I don't have anything. We're not able to see the fill change because the fill was set to the target graphic button fill has now been turned off. So we're not seeing that transition. If I chose to drop the icon in there, there you go. You can see we are once again getting seeing the visuals change when I mouse over that hit area. Okay, let's see what's next. All right, turning it into a prefab. So what I was saying before about wanting to be able to create multiple copies of this button. So we'll create something that we think is, basically a pretty good boilerplate button, right? We'll say, yeah, width 300 seems fine. Maybe it's a little, that 170 seemed a little tall. We'll go with a height 100. And some other things we might want to do, like we might want to add a little bit of padding, right? Our icon seems a little bit large. We might want to add a little bit of padding, or alternatively, we could also add like a max height. We figure the button is probably not going to get much taller than this. Maybe we want to instead say, instead of allowing it to fill the entire height, we want a max height of, let's see if I set this down to 50. There we go. So now, this will stay constrained to that height of 50. Let's see, or I guess alternatively, the other way we could do that is to use relative values, and we'll say, 0.25 and 0.75. So now what we're saying is that no matter what, the size of the icon should be 50% the height of the button, right? We're going from 25% to 75%. That is the allowed, the anchor points for our Y values. And so now, even as we scale this button, as we make it larger, as we make it wider, as we make it taller, I'm surprised the height there must be because, right, of course, we're saying 50% of the height. And so you can see here, this is still, even though it's scaling up, it still is being restricted to be 50% of the height. So real quick, just undo, get me back to my 300, 100 button. Looks good. My button label, right? Like, okay, maybe this, I'm gonna take it could be a little close to the right-hand side, right? Maybe this seems a little too close. We can add some padding on the right-hand side there. And now we're still allowing it to auto size, but we said, okay, no matter what, yes, go from 25% to 100%, but also leave yourself 20 pixels of space on the right-hand side and auto size yourself appropriately to the space. Okay, so now that we've got this is where we're going to make our first prefab, right? So we have our prefabs folder from before. We take this object, we drop it into our prefabs folder, and here it is. It shows up with the same name as this component, and you can see our component in our hierarchy, or not component, our game object in our hierarchy, it turned blue, and this, changed the icon to blue, the name's in blue. This indicates that this game object is linked to a prefab game object. So a prefab is you make a game object in your scene, and then you're able to save that exact configuration as you have it in your scene. You know, everything from like the name, the child hierarchy, all of the components, and all of the properties on those components get saved as a pre-made asset, which I can then bring back into my scene to create a copy. I'm just going to move it over. Let's see. I'm going to turn off the left button for the time being just to clean things up a bit. And I'm going to stop calling this right button. I'm going to change this to button 1. Here's button 2. And X position, I'm going to say minus 200. And this one back to 200, right? So I've got 2 buttons in here. Both are copies of our, I'm going to change this from right button just to button, right? This is our button prefab. We've brought in 2 copies. This prefab, essentially, this is the master instance that these 2 scene instances are referencing. If I open up the master instance, either by double clicking on it in the project hierarchy here, or by opening the prefab here, we can then, you can see our hierarchy has changed. We are now editing, and when I click on it, it highlights down here in the project view. We are now editing the master instance of this prefab. So if I were to come in here and turn off the icon, you will see that the icon on both of my scene instances is now turned off. If I come back here and I expand these out, you'll see the icon's been disabled. I am able to overwrite this on a case-by-case basis, so they still reference their master prefab, but if I need that icon on this second button, I can come back in here and turn it off. Now it's still disabled on this button. It's still disabled on the actual, if I open up the prefab again, you can see it's still disabled here. It has only been overwritten for this scene instance of the button. And when we do that, you'll notice up here there's an overrides drop down. So I'm back on button 1, which has no overrides. When I open this out, you'll see no overrides. When I click on button 2, the one where we turned the icon back on, when I open up overrides, you can see there is an override. If I click on it, it will show me the prefab source, what it looked like. You can see here it's saying that the icon was disabled in the prefab source. In our override, the icon is enabled. We can, if we wanted to, either revert, which means get rid of all of the changes that we have made on this instance and match it to the master prefab, or we can apply, which says take the changes we've made to this object and apply them back to the master instance. So you'll see if I hit apply, the icon on my other button will enable again because the master instance is now has an enabled icon again. So that is, it's a really important concept for understanding, okay, how do I take, make a reusable object and then on a case-by-case basis, tweak it to have, different labels, right? Like these labels are gonna be totally different between button 1 and button 2, right? This might be a continue, and this might be a cancel. These 2 buttons visually, they're very similar, right? We don't want to necessarily have to create, fresh buttons every time. We want to be able to use this prefab, but we still need that ability to overwrite the individual properties of the button to make it unique and so that it represents the actual button that it needs to. And again, right now, neither of these buttons and our prefab button, right, it has no responses, and nor should it, right? It's just a default button. When we're bringing a component, a prefab into our scene, it probably doesn't really have any real function yet, right? It was kind of this visual, just a component, a game object that we made ahead of time that we want to be able to reuse, but it has no context for what kind of a button it is yet. That's something that we have to then do in our scene view by linking things up. Okay, let's see. So that covers the prefabs. We now have the ability to bring in multiple buttons, restyle them, change their labels, all of that. Add a script attached to the button's click listener. Okay, so we already worked with click listeners a little bit. We saw how we can, add a click listener here, drag a game object into the serialized field, and then reference the components that are on that game object and reference the properties or methods of that component on that game object. So what we're going to do now is we want to actually have a script that is responding to this click, or at least or acknowledging that there was a click, and then we'll call some game logic as appropriate, right? So what we're going to do now is we're going to get into our first bit of coding here. We're going to create our first component that we're going to put on a game object. So we're going to jump over to VS Code now, at least for me. This is my code editor, VS Code. I already have my project open, and I'm going to create a new script. I'm going to call this, let's see, I need to get to my project, Unity tutorials, UI tutorial, assets, scripts, and I will call this, we'll call this button listener.cs, and this is going to be a public class button listener. It is going to extend, we're not going to see it here. It doesn't pop up automatically because I don't have the Unity package currently imported into this script, so it's not giving me that autocomplete just yet. But you'll see, oh, and I have a misspelling here as well. The MonoBehaviour is the base class for all components that we're going to be creating that are going to go onto a game object. If you want to add a custom component to a game object, the MonoBehaviour class is the base class that you need to extend. Let's see, and I'm going to save this. If I come back to my scene, we're going to recompile. I should get an error telling me that it can't find MonoBehaviour because I haven't included the Unity engine package yet. You can see here the type or namespace MonoBehaviour could not be found, or you're missing a directive. If I come back here, now my code editor also recognizes, okay, yes, there's a problem here. I don't know what this class is. And if I'm going to command period should give me the, there's, for some reason it doesn't want to give me an autocomplete right now. I'm a little bit surprised by that, but not horribly surprised. All right, so I happen to know that this is going to be using the Unity engine namespace. So using Unity engine, if I save that, you'll see it now recognizes, oh yes, MonoBehaviour. That's something that I recognize in the Unity engine package. And if we come back over here, we should be all cleaned up. And we can, from here, right? It's just, as of right now, it's an empty behavior. Nothing is happening on it. We've simply declared a new type, a new class, button listener. It's a MonoBehaviour. And because it is a MonoBehaviour, we can, when we go to add component, we will see here is our class that we just wrote, button listener. We can add that to this component. Now you can see this is showing up with this icon because I added it to the scene instance, which is tied to the prefab. So this is showing you that this is this little icon here with the script with the green plus. That means that this component has been added to, it exists not as part of the prefab, but as part of the scene instance. And again, if we go to the overrides, if I hit, I probably don't want to apply the change of button label to cancel, right? I don't want my button prefab to all of the time when I bring my button prefab into my scene, I don't want it to be a cancel button. It should still just say button label so that I know I need to set it. So I don't want to apply that one, but my button listener, maybe this is something I do want to apply. So on a case-by-case basis, I can say, okay, apply that change. You'll notice the icon here is gone. It's now just back to its regular script icon. And button 1 also got that button listener because we applied it to this master prefab. Okay. So from here, we want to start listening to these button clicks, right? First thing we're going to do is wire it up. So we're going to communicate from the button click in the scene to a custom function, a function that we write in our own custom component. So we're going to write public void on click handler, and we will write debug.log. So we're going to just log using Unity's default logging mechanism. This will print to the console panel inside of Unity. We're going to say, okay, so I'm going to print the name, the game object name of the button that has clicked, right? So there's a few different properties that we have access to just by default, by nature of being a MonoBehaviour. You know, every component, as we know, has a transform. It will see if I start to type transform, here it is, it auto-populates the transform attached to this game object. So there are certain things, just by extending the MonoBehaviour class, we get access to certain properties of that game object in the scene. One of them is the transform, because we know it always exists. Another one is the game object itself, right? This script is scoped to the component itself. This component, oops, sorry, it's going to reload real quick. Hopefully it won't give me an error. Here we go. This instance of this script, right? This particular script is the scope that we're working within right here. So when I say game object, when I say, if I ask it to, not that we use this a lot in C#, but if I asked it to log this, what you would see is it's logging, it should list button listener component. And we can go ahead and just test this real quick just to show. We're gonna have a void start, right? Start is a method that is called by default on any MonoBehaviour when a scene is run and that object first becomes enabled. It runs the awake method first when it first wakes up, and then in, I think probably usually the next frame, it will run its start method. So here we can go ahead and say debug.log this. Now again, this is coming from a button listener component. That component exists on these two instances, button 1 and button 2. When I hit play, here you are, button 1, button listener, button 2, button listener. So again, it is printing the name of the game object and the specific component on that game object. Let's see, and this is getting printed again. So, okay. So yeah, so I was going to do this using, game object.name. I was going to more explicitly say, print out the name of the game object that this component was on. But as you can see, even by just printing this keyword, we get not only the game object name, but we get the component name as well. So that actually works pretty well. And so what I'll do is just replace this on click, right? So we can leave the start there. It's empty. It doesn't matter. It's not going to do anything. It's just right now it's an empty function. It will get run, but nothing will happen. More importantly, we have our onClick handler, which when we run this method, we're going to log to the console this, which again is, in this case, it's scoped to this component on the game object. So if I stop this and play this, I need to add the listener here, right? So in my onClick, I can now drag, right? So that the function, the method that I want to call when the user clicks on this button is the onClick handler that lives in the button listener component on the specific button that is being clicked. So for button 2, I'm going to drag in button 2 game object. I'm going to find the button listener component on this game object, and I'm going to call the onClick handler method on that component. I'm going to go to button 1. I'm going to do the same thing. Button 1 needs to call the button 1 game object button listener component onClick handler method. And now when I run this, what we should get is, I'm going to click this button cancel. We get a print button 2 button listener. I'm going to click continue. We get that print button 1 button listener. So now each of these buttons, when we click them, they are currently triggering this method and logging their names. So that is one way to attach methods, listeners, to the onClick of a button. That is using drag and drop and serialized fields, right? So this kind of starts to get into dependencies, right? The button needed to know when it gets clicked, it needs to be able to tell us, and it needs to understand how it's supposed to route that message to the rest of the program. Right now, this is how we've defined it right here. This is how we're telling it how to route that message. As an alternative, I've got both of these buttons selected now. I can click minus to remove the onClick listener, and you can see both of these buttons have had their click listeners cleared out. So dependencies, providing dependencies. One way that you can do that is with serialized fields, dragging and dropping things in, right? The other way that we can do this is programmatically finding our dependencies through scripts. We're going to show a couple ways that we could do this. I think generally speaking, adding onClick method, it really depends on your use case. Sometimes adding it through here, the more localized the response, the more likely that you will want to or be able to easily add that response through the onClick, right? If in response to being clicked, the button doesn't necessarily do something that has a large effect on the rest of the program, right? For whatever reason, we have a button that when you click it, it just plays a sound effect. It doesn't do anything else. Well, that might be the kind of thing that could be really easily localized just to that button. We don't necessarily need a lot of other systems involved. We know that, okay, we click this button, or we want to turn on a graphic, right? It's very localized to this specific interaction. But if we think about something like a shopping cart, right? The user clicks that button. What needs to happen in response? We need to find the item that the button was associated with. We need to add it to the cart. We need to figure out, update quantities based off of how many other things are in the cart, whether or not they've already added this item before. There's all sorts of other pieces of the program that need to respond to this. And so when you have this sort of wide-ranging effects based off of a change in your UI interaction, you probably don't want to be doing this in this drag and drop way. This could be very tedious to make changes. It's very error prone, easy to break, right? And actually, we'll show that right now at how easy it is. Let's say that I do this the way that I had before, where I drag in my button and my button listener, and on-click handler. Great. So now I know that when I click this, it's going to run this. All right, cool. No problems there. But, I run into an issue where I don't really like what I named this, right? On-click handler. What if I decided this should really be, on-click listener? That's a better name for whatever reason. I needed to refactor, right? I changed the name on my method. And now when I come back over here, we're going to find that Unity no longer knows about that method. It disappeared. Now it's missing. It's missing the on-click handler. And so now if I try to run this, we're not going to get any response. Or at least we still get the visual response because all of that is just very localized to the component. But the listener, the on-click listener method in our button listener component that was printing out the name of the button, that is no longer being called. We're getting nothing, no output in the editor. And so this is one of those instances where, because these things are subject to changing, adding them through the editor as serialized fields, it is, it can be really problematic. It's an easy way for things to break later on. And you can see there's no error is even being reported. The fact that this is broken, nothing is being necessarily, other than the fact that I'm not getting the output that I was expecting to get, nothing is telling me that there's a problem here. And so that's where it can get really hard to debug. As your project grows, it can get really hard to debug this kind of a problem because you may just not notice that something has basically become disconnected is what's happened here. So if I change this back to on-click handler, this will recompile. I'll probably still need to restart. Let's see. Oh, maybe not. Even with the play mode. There we go. Look at that. Unity has gotten a lot better about this, I will say, as we've lately. It has updated there, and so now actually you can see. But again, note. Let's see. I'm in play mode. We'll see what happens when I exit play mode, whether or not it actually kept its reference. Oh, it did. Okay, cool. Did keep its reference. So there you go. All right. So if we're not going to be providing this routing, if we're not going to be saying, okay, you want to report that you've been clicked. If we're not going to be doing that through drag and drop inside the Unity editor, and we want to do it programmatically through a script, well, this is where we can do it. So the next thing I think that we're going to talk about is the get component. Let's see, serialized fields, drag and drop, get component, and require component. Yeah, okay. So the other way that we can attach to that button component, right? We want to attach to this on-click listener. I'm going to go ahead and remove that one. We can use a get component function. This is one way. We're going to get component. The component is a button component. You can see when I brought that in, it automatically imported the Unity Engine UI namespace, which is where the button exists. So get component button. This you can call right from our MonoBehaviour. Get component is a method that's included with that, which will look for a component on the game object at the same level as this script, right? So this button listener script refers to this script on this game object. This game object is being told to find a component on itself at this specific level and return that component. The button component has an on-click property, which is that same property that we're accessing through the drag and drop functionality of the editor, which has an add listener method where we can pass the listener to respond to that click event. So save here, come back over to Unity. This will recompile. And when we run our scene, you'll see our two buttons. They have nothing in their on-click listeners as assigned through the editor. They will continue to stay empty, even though we are assigning a listener programmatically. that listener does not populate into this on-click field here. This is specifically displaying click listeners that are added through the editor interface with the plus and minus and the drag and drop, right? So they don't show here, but when we click on this button, you will see in our console, we get the expected output that click event is being routed to the listener that we added programmatically to the button. So that is the other way that you can add listeners. And there are some reasons why it's preferable, and one of those is that it solves to a certain extent that same problem that we had before of changing the name. So if I change the name on my handler, as before, I changed this to listener last time, right? Now, if I change this to listener, and you're already going to see, my script already knows something is wrong because this method doesn't exist anymore. It's supposed to be able to find this method within the context of this script. It says, I don't see an on-click handler method available. Something is wrong. And when I go back to Unity, we'll see the same thing. It's going to report to me that there is this error in my script. So you can see the renaming, when we do it this way, the renaming gets caught as a problem because there's now this disconnect, but it's able to recognize it, as compared with when we added it through the on-click listener. That does not get recognized, that this function is missing because Unity doesn't have the visibility into that script in the same way as it does when we're doing it programmatically, basically. So now that we've got this, there are some, if we do need to rename it, there are we can either just do this manually. We can say, oh, okay, this should be, listener. We can see that this is incorrect, and now the names match. Alternatively, within VS Code, and I'm sure within other code editing platforms, they give you renaming functions. So sometimes we do have problems, like we have a typo, right? Instead of on click listener, let's say we had something like that. We had a typo where the K and the C are reversed, right? And we want to fix this typo. We don't want that typo to persist through our project for all time. And so when we want to change it, we can F2, at least in VS Code, F2 allows you to rename a symbol, a property, a method, a class, and within the entirety of the project that VS Code knows about, it will rename that symbol everywhere. So you can see I can change this here back to on-click handler, and it updates appropriately throughout the script. It would update throughout the project. If I had other scripts that were referencing this method, it would know about those as well. Everyone would receive the update. And so you're able to make those kinds of changes to the naming conventions of your properties, of your methods, without breaking on-click listeners and things like that. Now, there are things that can still break with this, right? And this is, coming down to the fact that we're saying get component button, and get component, this version of get component specifically looks only on the game object that this script, our button listener script, is attached to. So it's only looking on this exact game object, right? Now, if we, let's say we removed this button. Let's say somehow this button got removed, right? When we go to run this, we're going to receive an error. At least we should. There we go. Object reference not set to an instance of an object. Button listener, line 8. If we look back at line 8, get component button, this is returning null. And then we're trying to access the on-click and add listener functions of a null object, because when it tried to get the button component, it didn't find one, right? So this is, adjustments in the scene view. This can also create problems where this was expecting to find a component that no longer exists. And at the very least, it does report an error, so we're able to debug it, again, better than we were the previous breakage of the on-click listener. But it's still, you do have this sort of, the script and the scene structure, they have some dependencies on each other. And if we don't make those dependencies explicit, or we don't put in any kind of safeguards, you can end up with these issues where you change something in your scene and it ends up breaking your code. So if I come back to here, overrides, I'm going to revert the override, right? The button was removed. I'd like to bring it back. There we go, revert the override, right? So one safeguard that we have here is the require component. So we're getting into the area where we have to make decisions around how we want our UI, the UI, the scene, the gameplay hierarchy. We need to make some decisions around how we're going to structure these things to make sure that we prevent errors like this from cropping up. So one of the things that we can do is we can require component type of button. So the require component modifier or attribute rather, this says that in order to place a button listener on a game object, that game object must also already have on it a component of type button. And so you'll see when we come back to here, if I try to remove this component, remove component, can't remove component because the button script, button listener depends on it, okay? So now we're preventing that from happening. And on the flip side of that, I'm gonna go ahead and make a new game object, add a button listener component to it, right? There's no button component on this yet. When I go to add button listener, you can see it automatically, right? So I added the button listener component and it automatically brought in the required button component. It's not hooked up to anything, but you know, the graphic, for instance, there's no other image. All the other dependencies still need to be created by us. But adding the button listener, it knows it needs a button because we've told it it needs a button. And so it brings in that component, right? Now, the one thing about this, again, is it forces a specific structure in the scene. It's now requiring button listener, this script, has to exist on the same object as the button script. Depending on the exact scenario, you may want a little more flexibility in your objects, right? Sometimes, you know, we oftentimes have an event that is occurring somewhere lower down in our hierarchy. For instance, with our button, the click event, the actual click is happening on the image on the hit area, but we want to be able to grab the event or listen for that event higher up, right? So we're, you know, the components are the game objects that are reporting an interaction, or that, you know, like the components from lower game objects, from child game objects, communicating with the parent in a way where that structure has a little bit of fluidity and it doesn't break really easily when we start recognizing, oh, like maybe I needed to rearrange these a certain way to get a certain visual output. And maybe I needed to put this button inside of another container, and then, you know, use that to be able to really specifically position things. But, you know, again, I'm forced to have these components in certain places because I'm using things like get component. There are some other versions of get component that allow us a little more flexibility, such as get component in children. This one will look downwards through, it starts at the game object that the component is on, but then even if it doesn't find it at that game object, it will continue to look into the children until it finds a component that matches the type you're requesting. So in this case, right, get component in children button. This would allow us to find a button component that's further down in the hierarchy, or we can get component in parent and find a component that is higher up in the game hierarchy. So if this button listener was on a child and we needed to grab it. So actually here I can do this. We're going to remove the require component. I'll comment that out so that that's no longer active. I'm going to say get component in parent button, and we'll use this on click listener again. And so now what this would allow me to do is to remove the button listener component from here. I could create a new child. Again, we're seeing this because I'm modifying a prefab. Add component, button listener, and when I run this, button 2 will still function appropriately because the button listener is grabbing a component in the parent, which means it's looking, it doesn't find, it still starts at the game object you require, at the game object level that you're requesting, right? Button listener, it looks here, doesn't find anyone, goes to the parent, looks for a button, finds it, and now returns that component. So those are two, the get component and the require component. Those can allow you to kind of either force a specific structure for your game objects or to give you some fluidity in that structure when you don't really know, as long as you know like that somewhere up in your hierarchy is the component that you want, then you can use things like get component and parent, right? But it gives you a little more flexibility because it doesn't have to be on a specific game object. It can just be somewhere in the hierarchy that we know about. Another way that we can get some flexibility in our button events and listening for those events and broadcasting them to the rest of the program is to use actions. And so what we'll do next is we're going to add a public static action on our button listener class. So that's public static action. That will bring in the system package, and we'll give this action a name of, button click action. Okay, so these actions, they have a couple of methods on them, but the one that we're looking for is invoke. And so what we're able to do here is actions, they have this invoke method. They also are able to take listeners, essentially. And these are a little bit different than the add listener function of the onClick. The way that you assign handlers to actions, and this is sort of like a pub sub sort of a thing. You're able to use the plus equal operator to assign a delegate that gets, which is just a method function that we're going to be adding to the other side of this operand that will get called when the action is invoked. So button click action plus equals, and we'll say button click action handler is the nomenclature we've been using so far, so we'll stick with that. We can go ahead and just for sake of showing this off, we say public void button click action handler, right? And we're going to do a few things here. So we're going to change this just for some clarity. We're going to say, okay, the click handler, we're going to debug on click handler, and we're going to add the name of the component in game object. I'm using this string literal with the $, open quotes. This allows you to simultaneously log some text, and then in brackets, it allows you to escape the string, like you're logging a string, the brackets allow you to escape the string and insert a value, like it puts you back into the scope of your script. So in this case, I'm able to ask it to do this and log, the same as we had debug.log this before, it's gonna be that same reference. Now just embedded into this string literal. And I'm going to copy and paste that for differentiation down here. We're going to say the button click action handler, that one also. So now I've got the on click handler, the button click action handler, right? And I'm going to add that listener. I'm going to put that in start. So when this script starts up, button click action, add a listener to it, which is the button click action handler. And in the on-click handler, we're going to invoke that action. So I'm going to also uncomment the get component so that we're able to, receive that initial click again. And so what's happening here, from start to finish, we are going to programmatically add a listener, the on-click handler. That function will get called when our button component triggers its on-click message. That will trigger this function, on-click handler. It will log on-click handler. It will then invoke this public static action, button click action, which has been told to, when it is invoked, call the button click action handler method down here. We'll just do this real quick so that you can see what happens. Now, what we're doing right now doesn't make a lot of sense because we're still in the same script. We're working still inside of our button listener script. But because we have defined this as a public static action, that means it exists on the button listener class and will be accessible to classes outside of button listener once we have a second class to work with. Right now, we're still just working with this single class, this single component, right? So we come back here. I'm going to click this. We're going to get 2 logs. Button 2, let's see. Oh, I removed the, that's why. Actually, button 1 should work. Yeah, there we go. Button 1 still works because button 1 still has the structure from before. Button 2 is not working because I have this game object, this child object with the button listener instead of having the component on the button itself. The button 1, when we click it, you can see we get the on-click handler for button 1, followed by the button click action handler game object. Now this is interesting, followed by a second button click action handler game object. And then we get the button click action handler button 1. So what are we seeing here, right? We're seeing this debug log output, on click handler, that's the top one. Then we're seeing button click action handler. That is this. Why are we seeing it twice? Well, we're seeing it twice because there are 2 instances of the button listener script in our screen. One is on button 2. One of them is on button 1. This is both of these buttons in their start function. They said, okay, when the button click action gets invoked, and again, remember that's happening at a class level, the button listener dot button click action. That's happening at a class level. We can be a little more explicit here. Button listener dot button click action. And when this action is invoked, each instance, right? Each instance of button listener component in its start function says attach the button click action handler function for that instance of the component, attach it to the action. So in our scene, we have 2 button listener components. Each of them is registering its own button click action handler method to trigger when the public static action button click action is invoked. So that is why we see, we'll have to run this again, right? So I click it, let's see, run this from the top. Click here. That's why we're seeing 2 logs for button click action handler. game object button listener. This is, unfortunately, we're not seeing game object button listener. Okay, here. We're actually seeing it 3 times. My mistake. My scene got a little dirty and I didn't notice. So we have the button 1 button listener. We have the button 2 game object child button listener. And I added this other game object, this empty one, whereas, you know, showing the require component, we have a third button listener. And here they are being logged. Each one of them, each one of these components has created a connection between the public static action and this particular method, right? Each component runs its own start function. Each component wires up this connection. And so when the action is invoked, each component, all 3 components, end up triggering this log statement from their particular scopes. And you can see, you know, unfortunately, I named this game object. If I name this, you know, third. Oh, again, I need to exit this for this to take effect. Let me exit here. Third listener, right? So that game object is now called third listener. When I come back in here, click the button. Here we are. Here they are reporting. Game object is that guy. Third listener. Here it is. Button 1. Here it is, right? So what we're seeing here, though, most importantly, is communication across game objects. We invoked the action through clicking this object, and other objects not involved in the interaction had a response. So this is how we can start to separate our game logic from the actual, from the events, the event messaging itself, right? We're able to create a separation here so that they don't all have to live in the same class together. So what I'd like to do next is to show how this can work across scenes and with, you know, communicating the button click from the button to another game object in another scene, which has logic that runs, you know, sort of separated from the button click and is busy controlling its own stuff. So first thing I'm gonna do is just clean up the scene a little bit. I'm gonna get rid of my third listener. I'm even gonna get rid of button 2. We're just going back to our single button, continue button, and we've got the button listener script, the button component, and we are going to remove, right? We don't need this button to listen to itself, which is essentially what we had before. We still need the action so that it will broadcast out the message, but we're going to be listening to it from somewhere else. So what we still have here is we still say, okay, on startup, find my button component, and when the button component sends the on-click message, here is a listener on-click handler. We're going to log that it occurred just for the purposes of debugging and tracking it. And then we're going to invoke this public static action. So what we'll do next is create another script. This is going to be our gamelogic.cs. Put it in our scripts folder. This is also going to be a MonoBehaviour. So public class gamelogic extends MonoBehaviour, and you can go ahead and save this. I'm going to jump back over to the Unity editor just so it can compile. And this is important so that it knows the script is there, so that it can then give you that IntelliSense until the Unity project kind of knows that it's in there. You're not likely to get all of the IntelliSense that you want. The project needs to recompile and add that new script to its internal list of scripts that it knows about. And of course, we're seeing that error because we don't have the Unity engine namespace in here. Let's see if we still no code actions available. My goodness, that's frustrating when it does that. But at least, as you've seen, it gets better as you get going and the program starts to recognize what you have available. So public class, game logic, MonoBehaviour. So now what we're going to do here, this is going to be a script that sits on a game object in a separate scene from our button. And you can imagine this would be something like if we have a nav bar, you know, that is in one scene, the user clicks it, the other scene that is controlling the actual content, you know, behind the nav bar, that needs to listen to the click event on the nav bar and update itself appropriately. So again, game object in another scene with another, you know, that it will listen to the event. So from here, we're going to actually do the same thing in our start function that we had before. We need to listen to this public static action and assign that. So we've got in our start function, we will be able to access the button listener dot button click action, again static action, plus equals, and we're going to have a button click action handler here, which we write. This is our void button click action handler. It takes no arguments, and from here we are going to let's see, in order to kind of demonstrate that this is listening, we can of course just have a basic debug statement. We're going to debug log this, and you know, what we can also do is we'll have our own field here that we increase. So we're going to have a private int click count, and we'll start that at 0 every time. All right, and when the button click action handler is fired, we're going to increase our click count by 1, and then we will log that click count. And again, I'm going to use that string literal click count, open the braces, click count again, so that we're able to see that alongside with the label. Okay, so now if I come back to our sample scene, we have our button 1. And okay, so the first thing that I can do to demonstrate this is we'll just add a new game object, add the game logic component to it. When we run this, we should start seeing that click counter already. So again, across game objects, we hit continue, we click the button, right? It invokes, like it goes through the on-click listener assigned through the button listener script, which then invokes the public static action, which then calls the delegate method on our game logic. And you can see here it is, we've got the on-click handler, and then here's our debug this thing right here, the button click action handler. We can see that being called, and we can see our click count of 1. If I do it again, we'll see it's increasing. We're getting those logs. All good. So that's across game objects. We can also do it across scenes. If I create a new scene, I can just use a fully empty scene, right? I'm going to save this. I'm going to save this into our scenes directory. We'll call this game logic. And I'm going to create an empty game object. We'll just reset this transform just because, why not? Get it back to 0, add a component, game logic, okay? I'm going to, and what you're able to do within Unity with scenes, you can have multiple scenes loaded at the same time, which is very useful because it allows you to use scenes to compartmentalize parts of your game, such as a nav bar versus the overarching game logic of our main application. So I can drag the sample scene back into here. We now have 2 active scenes being displayed at the same time. I'm going to remove the game logic script that was in the sample scene. Now it only exists in our game logic, and I'll call this, game logic game object, just so that we can see it when it logs. And from here, I can go ahead and play again. And we're going to see, even now that they're separated by scenes, I am able to get this exact same functionality communicating between the two of them. And so this is how you're able to really separate out things like interface events from the response to those events. The last thing that I want to talk about is the actions versus the event action keyword. So when we say public static action, we're exposing this publicly to other classes so that they can listen to it. But in exposing it, we also are making it available to be invoked by other classes. So which we really don't want, right? Only the button listener knows when its button has been clicked and therefore should invoke the action. Something like the game logic needs access to it to listen to it, but it shouldn't be able to call invoke on that action because it doesn't know when that action has occurred. So using the public static action, it is, it's very convenient, and it's great for exposing this, but it does give us some scoping concerns around who has the ability to invoke that action. So one way that we can fix that is if we add the event keyword to this action. You'll see this one still is good. Everybody's okay here. But when we head back over to game logic, we now have an error. Button click action.invoke says the event button listener.button click action can only appear on the left-hand side of the plus or minus, right? So we're saying that we're no longer allowed to access it in the same way. We're only allowed to access it in this way of adding a listener, subscribing a listener to this action. We're no longer allowed to invoke it ourselves. And so through adding the event keyword, we are now able to keep the action available publicly in other classes for listening, but prevent its invocation from anyone other than the class in which the action is declared, which is in this case our button listener class. And so that is just one little safeguard. Again, as your program grows and you have events flying around, these things can start to get very difficult to debug. And it gets even more difficult to debug when you have bi-directional messaging, as this idea that we can potentially invoke this event from outside of the scope that really knows when the event has been triggered. And so using that event keyword in addition to your action, that can kind of help mitigate that and at least keep this button click action omnidirectional. It only will communicate outwards from this script. It can't be invoked from outside, right? All right, that's where we're going to end today's lesson. The next time that we jump back into this, we will start to use these tools that we're working with and these techniques that we're learning in the context of actually building out a little bit more of a functional UI rather than just kind of demonstrating them within these, these test scenes that don't have any real structure to them. So, see you next time.